All right. Hello, everybody. Welcome to this new session. Today, we're going to be talking about IoT going into the real world and what can possibly go wrong. I'm Gregory Menvielle. My Twitter handle is at @PureMedium. You're welcome to drop me a line, whether it's 140 or 280 characters. It's always fun to hear back, get some feedback on presentations. And today, we're going to be covering what happens once all the hard work you've done with the IoT device, you've done the hard work, and you start to release that out to others. And the reason we're very interested in this is this number, 45%. 45% is actually called algorithm aversion, which is the rate at which people are going to stop to trust a device or an algorithm if they see the device making a mistake. And that's a fairly large number to begin with, and obviously it can lead to downfalls in businesses, downfalls in operation, because we stop to believe in what we see. A very good example is when you enter a destination in your GPS, then you get a route, turns out to be not exactly the route you expected, and then the next time around, you're going to be a little less likely to use the GPS. And the minute a device goes into the field, into the real world, there's a chance that this algorithm reversion is going to happen. And for me and my company, smarttrans.us, it's quite important because we're looking at all the elements that can lead to fatigue-related accidents. Just to give you an idea, the cost of fatigue-related accidents, beyond the horrible human cost, of course, but once you go beyond that, it costs society over $108 billion a year in the US alone. So there are some IoT ways to go around that to get better, but we want to make sure the devices are working well when they're outside. And today I'm going to share you some of the stories the lessons, I should say, we learned deploying those devices, and also lessons we learned from other projects in the back when IoT goes into the wild and everything that can go wrong. Now, on the topic of smart trans, if you guys are makers, I'm going to invite you to join our community and build your own sensor kit so you can help stop fatigue-related accidents. Starting early December, we're going to have a community follow-along build, and if you want to have fun, have your own little device, and sensors will help you go through the process. And you have the link there if you're interested in doing so. Or if you don't like to build, you just like to play, you're welcome to download the app as well, so you can go ahead and see how we can prevent fatigue-related accidents in transportation. So it should be pretty fun. So here's what we learned. Everything is becoming connected. The whole conference right now, the past 2 days, has been about IoT and all the wonders that IoT is supposed to bring. That's the theory. In reality, it doesn't always work this way because data and real life and humans don't always interact pretty well, same as device. So let's look at some of the factors that can impact what IoT does. And that's something important to do because if you watched Apple's keynote recently for the iPhone X, they did that great demo with visual recognition. And during the demo, everybody thought it was pretty cool, pretty neat. Then once the keynote was over, one of their engineers tried to run that on his phone, and it didn't work. And all of a sudden, the feedback became pretty negative. So think about it. Apple, pretty close to a $1 trillion company in value, versus our companies like yours or mine doing IoT projects. If it happens with those guys that they have problems once their device go out in the wild, likely it can happen to us. So the first thing that creates problem on a regular basis is the difference between how we think people are going to be using our device versus how they really use it. Now, let me give you a great example that I've seen lately at a train station in France. Now, for those of you who do not speak French, the sign says, do you like to be able to buy food inside the train station? And you can see about 30,700 or so people said yes, because there's a button that says yes. And it looks like a great device to get people engaged at station. It's an IoT device, so you can really measure in real time what's going on. In reality, it's horrible because first thing, that's my daughter here, and it's only kids playing and pressing the buttons. So already that trade bias the data you're receiving. The other thing that's pretty interesting about this device, if you look closely, the left-hand side where her hand is at, it's a button. That's the part that says yes. So it's very simple to say yes. However, to say no, that's where the QR code on the right is at. And that's where you need to scan the QR code and become such a horrible process. Chances are you're going to be missing your train to begin with. So that's an example of an IoT device that was supposed to capture customer data. That's actually totally missing the mark because the way people are using it, mainly kids, does not reflect at all the intent that SNCF, the train company, wanted. And that can happen to all of us. And whether we're following the lean startup methodology and MVPs and so forth, once people start to use a device, they always find new and interesting ways we had not thought of. And we need to protect against that to be as prepared as possible. The second issue we run into a lot, regardless of where the IoT device is at, is the issue of power and battery power. Based on what you're going to do, you may be able to tap into a fixed source of power. For example, if you have sensors inside a building or captors, you may be using batteries. We also see many companies going toward solar chargers or solar batteries. There can be a mix of two systems. But regardless, you really have to think about how important power is to your application. We talked about sensors inside a building. For example, you may be hooked up to the building wire system and power system. However, what happens if the power goes wrong? And that's where you really have to define, once you start to build your device, what are your fail-safe scenario? Do you need power all the time? In which case, you're going to need to have access to an alternate supply. Or maybe you don't care if power is off, and that way it's just going to be a matter of writing enough logic so that when power resumes, your data and your algo is going to be able to feed back data. So there are different options there, and spending time to evaluate them become very, very important, because once the device is out, you're going to be hindered by this. The other fun part that you may run into is that people may think they have power, but they don't have as much power as they actually do. We recently ran into this when testing our device with car power adapters, the little USB stick you can put inside a car cigarette lighter. And between what the car manufacturer claims as the output and the reality, again, there is a gap. And you have to prepare for those things as your device goes out. If not, the device fails. Technically, it's not entirely your fault, but everybody sees that as being your fault and reflects extremely poorly on what you do as a company and as a product manager. So worrying about power is important. The second part that we should talk about is sensors. Sensors are becoming very, very cheap, easy to find, easy to get. But they're also very good at lying, in a sense. For us, we have a temperature sensor, for example, and a sound sensor. Those things, based on the amount of power and power supply you put through, they will register a different type of information. So if you put 3 volt versus 5 volt inside a temperature sensor, it's going to give you a different reading. And it's very easy for models to go from one version to the other. The other part that we're finding interesting about sensors is that it's actually pretty easy to fool them. For any of you who have used a Fitbit before, you will see that Fitbit is able to track your sleep patterns. And if you look at this pattern, the one on the screen at the moment, it looks incredible. It's wonderful. There's only one little issue. This is actually my mom's pattern on this one. And she loves to play Scrabble so much that when she holds her device like this, she becomes so still that her little Fitbit thinks she's asleep. So here's the fun part. Your device could be like a Fitbit tracking people's sleep. It looks perfect, just the end user is doing something entirely different. And again, the end user is not going to think, maybe I should not be playing Scrabble that much and I should move a little bit more. They're going to think that the device you sold them is not working, and now it becomes your issue. And that's something that does not really happen when you develop the device inside the lab and you build upon it. So that's something you have to watch out for. Another funny example, apparently I was able to cover 7.7 kilometers in 48 minutes. That'll tell you how fast I run on a regular basis or not. But look at the map. I went from France to the US in about 48 minutes. All this has to do with the way the GPS works on my watch or does not work on my watch. And it's coming from sensor data. Again, that could just imagine you're sending that data back to your big systems, whether it's SAP like the way we do, or Amazon or Azure, whatever be it. You're getting that data back, and it's going to start to raise a lot of flags in your system, whereas really the problem is coming at the sensor level. So being very picky about the type of sensors you write, being able to add a lot of logic about fail-safe, about false positive within the logic becomes pretty key for everybody. Now, the other challenge that we're running into on a regular basis has to do with connectivity. And by connectivity means, does the user have connection, some sort of Wi-Fi 5G connection between the device, the IoT device, and the server? Now, in our case, if you recall, we're trying to detect fatigue-related accidents. So that data we're collecting, it's pretty important. That's how we're going to find out if the guy is falling asleep or not. So in our case, we decided to put most of the logic on the board. And that's a choice. It comes with consequences in terms of power, in terms of security and backup. That's one option. The reason we decided to do this because we feel it's a critical element, and we cannot afford to rely on systems such as 5G, Sigfox, and LoRa. Those tools, 5G, Sigfox, LoRa, they're supposed to be able to carry the data almost anywhere you're in the world. But they do not work all the time. They come with their pros and cons. I'm sure some of you might have tried playing with them. You may have other alternatives as well. But here's the key part. You have to think about your IoT device, what it does, and how much connectivity you need to send through. You may be happy with those systems, or you may go our route, which is more the onboard-based device, what people are starting to call fog computing. Regardless, you're going to have to pick one or the other. There's no right or wrong answer. What you can do, however, is really explain well to your end users the approach you're taking, so that if indeed you're relying on a permanent connection, maybe give them some visual when they are connected or disconnected, so they're not expecting anything from the device. Similarly, based on how you're handling your big data system in the background, try to figure out if the fact that the device is no longer sending data is quote-unquote normal because you're in a dead zone, which you should be able to map, or because the device is no longer powered or was broken, or whichever the reason is. Because all this information will help you develop a better product for the end user, which is what you want. Now, let's go into a bit of the business of data, because realistically, when we're building IoT device, it's to collect data, and data can really mess us up. There's the data that we're collecting from our device that we've seen can be problematic once you hit the outside world, but there's also other data points that we may be using in our applications to make them work. Let me walk you through a few examples that we've seen of data creating problem. The first one is that, according to the US State Department, Niger is now in Nicaragua. And really, the reality behind this is just the State Department uses a country code convention that does not match the more recent ISO country code convention. So when the data comes back from the State Department with the travel warning, you may start to map it, and you're going to find yourself in a location that makes no sense. Now, this type of data, you're fine. There's about 186, 187 countries in the world, based on what people think of Taiwan, and you're going to be able to write a filter on this. You're going to be good. But start to think about all that data you may be reusing that may be coming from a much larger fire hose, where you're not going to be able to write a filter for each and every single country to map it properly. That's where it becomes problematic, and that's where we're using external data within your application, within your IoT device, and infra becomes a challenge. And what we found in our work is that all the data that comes back from any sort of gamification related site is horrible. Most of the time, it has been tampered with in a way that will drive you insane. And I'm actually going to dive down in a few examples linked to a site named Strava. I don't know if any of you are on Strava. If you are, feel free to say hi as well. Will be fun to link up. But basically, Strava is a site where you can upload your training. So you're going to run, you're going to on a bike ride, you upload that to Strava, and then you can see what your friends have been doing. You can gain points, gain badges. In theory, it's great. And I've actually seen many companies use Strava to build their own IoT tools, their wellness tools. I've seen cities use that information from Strava to build traffic patterns, to analyze traffic patterns within the city. So it's really a tool that's being used a lot, whether it's healthcare, smart cities, places where IoT happens, so to speak. Here's the problem with the data from Strava. You have regular users, like some of us, and then you have users who are very creative. You have users who love to do what's called geo art. That's on the left-hand side. So literally what those people do, they go around a city and they try to draw some things, animals, whatever you can really think of, they will try to draw it. So that's really cool from an art standpoint. However, from the Strava API perspective, it's just data that it will send back your way. So imagine if you're a city and you start to build your traffic patterns based on giraffes, based on gorilla, whatever people draw, that will lead to major problems. But we've seen it happen, believe it or not, and it's always scary. Now, those are people who just use Strava for fun. You also have people who use Strava to cheat or make themselves feel better. When Strava came out for a long time, there was a site named digitalepo.com. And if you're into sports and you know EPO, you're going to see where it's going. But pretty much on the website, you would upload your training file and you will say, okay, I want to pretend that I went 20% faster than I actually did. And what this site would do would actually tweak your data to make it look real, just 20% faster. Then you go to Strava and then you go up in the rankings and everybody thinks you're a superhero for what you've just done. Now, in a sense, if people want to do that to stroke their ego, that's fine. But again, think of it this way. When you connect into their API, and by the way, I'm using Strava as an example, but there are tons of sites that are the same way. So if you tap into that API, you're getting the data back. And you have no idea whether the data was coming from a guy who wanted to make himself look better or from someone who loves giraffes. And then if you use that data within your IoT device, that can become very, very problematic. Because again, your IoT device may be something pretty cool used to track people, let's say, fitness levels and whereabouts. And actually, they use that to draw their giraffes. So it goes against what you created the system for. Now, IoT has to do with location and geolocation in some way, shape, or form. And there we've also seen many, many interesting things. There's, of course, the case of how long does it take for a GPS to get a lock on you, and whether the GPS is working well or not based on your coverage, your position in the world overhead. Indoor location can be really fun. And of course, you also have the data that's being returned to you that's absolutely fake. Let me give you an example. We've had a customer on for one of our product being very happy because they saw the result on the left-hand side and thought that they actually had 17 customers in that area of Paris. Turns out some of the users were skiing and not in the middle of Paris. We know because some of the skiers were part of the company. And what happened there is actually pretty simple. Once you start to go in areas that do not have very good cell tower coverage, and your cell phone geolocation is on certain settings, the cell phone company may not return your precise location because they don't really know it. They will instead return the location of the pipe where really their data center is at. And that also becomes a problem because what we're seeing nowadays is a lot of people are building their IoT device and are using the cell phone geolocation to merge the data on the IoT device and the geolog. And obviously, if you're getting to those scenarios where people are not where they're supposed to be, well, all the data, all the work you've done is wrong. And then it goes back to that 45% of the time where people are going to be looking at the results afterward and we're like, wait a minute. I was skiing in Paris. I was skiing, sorry, in the middle of the Alps, and it's telling me in the middle of Paris, this device is horrible. Let me go and give it a horrible rating on Amazon. Similarly, if you're doing things that relates to people's safety and security, that becomes a lot more problematic. So the easy answer here would be, say, well, let's not worry on the phone GPS data and put the GPS inside the device. But then at that time, if you take that approach, which we're doing that in our case, but obviously it increases the cost of the device, it increases the power curve and the energy that you have to provide to the board. So there are always trade-offs when it comes to IoT and building devices that you have to worry about. Going back to data, the best advice I can give you guys is read this. You have to trust the data you know and be very wary of the data you don't. So data you know is going to be data that comes from your IoT device, because hopefully you've built enough test and fail-safe system to know when the data is real, reliable, and it's not. Everything else, everything you're going to gather from external API, even if it's open government, open source, that's just information, and you have to start to do the mix and match. So for example, if you see that I'm claiming to climb a very difficult ride very quickly, and you know me and my height and weight, and there's no way I can go at that speed, then your algorithm should be able to pick that up. Now, obviously, based on what your device does, this can be very simple. If it's just a GPS-like system, it's simple to track one person's progress. But on the other hand, if you're doing captors and sensors for flood management, for energy grid prevention, that becomes a lot trickier because you have to worry about the device itself, whether it's working or not, and the other data coming back in. And that's where big data and AI becomes quite key and quite important. Now, the last part, as we come to a wrap, is that remember that there's a tendency to think that AI is going to be able to bring a lot of information and help to our daily lives, and we're building devices that we feel and hope are going to be preventing and putting an end to some major problems. But our user is going to be very unique. Each and every one user is going to be unique, not just in the way they use the device, but also in the way they approach life and their belief systems and what they feel the device should be used for. So as we do a lot of technology, as we start to talk about, MapReduce, big data, AI, we need to remember that at the end, we're here to help humans, and we need to put them back in the center of the experience. And as you do this, as you release your device to humans who are in the real world, you will see they will get a much better agreement level with your device, and you will get much happier customers and a much better word of mouth. All right, that is actually the end of the presentation. I wanted to make sure we went through this in about 30 minutes to allow some time for some questions. So thank you. Someone was mentioning all the unintended uses for these devices. I think that's what you're going to be running into the most as you develop systems and product. So that the intent and the actual usage is extremely, extremely different. All right. So once again, you guys will have links to the presentation, and you're welcome to drop me a note on Twitter. My Twitter handle, I will put that in the chat. It's at Pyramidium, Pyramedium. And some of us, I know some of the presenters could not set up the one-to-one time. However, you guys are welcome to drop me a note. And if you need to to set up a one-to-one time, we can make it happen. No problem. All right. Thank you very much. Thank you, Sir Technical, and thank you, Marcus. And enjoy the rest of the conference. Bye.